So yes, how many of you did this insert function?
Ma'am, I had a doubt that insert like how Bhuvnesh did previously.
Yep.
How is it this one different from the previous one?
See, okay. This previous one was like you have a position, a specific position where you need to enter this number, right?
Yeah,
But in this, you don't have a position. You just have a number. And according to the number, you decide its position yourself. Like this is a sorted linked list. If I give you 11, its position should be between 10 and 12, right?
yeah, yeah.
But if I give you the number as, let's suppose 1, then its position should be at the start of the linked list. So
Got it.
you need to compare it and then you need to insert it. Okay, Christian did it. Yes, guys, how many of you want me to explain this or just you want the code? Yep, I cannot see anyone's message. Code should be fine. I can do it now. Okay. And Kishan, yeah, I saw your code, the diagonal one. Also, I'll just test it. I was checking it, like, was it giving you the answer?
What answer?
Like, what is the expected answer of the matrix that you have taken? The maximum answer, like
Minimum
the
answer, right?
minimum answer, sorry. Yeah,
7.
7. Okay,
Yep.
okay.
Even that one is also getting printed. I've added this out.
So, like, what's the problem with the code then?
I don't know. Like, I'm not able to get. I think every time that min value is getting reinitialized, I guess. But I have taken that as a global variable too. But that is also not working.
So you are saying that you are getting one of the variant as this, like
It's
minimum, right?
yes, yes.
But when you are printing your minimum answer at the end, you are not getting the correct answer, is it?
Yes. Actually, like say for example, like for the first case, for the first like when I got a magic number first time, that
Hmm.
is going to like get a absolute sum of the one which I have passed with the magic square, and it will give some value. I mean, as a
Mhm.
minimum value. At the very first, take an example, it is 29. The sum we got as a 29. And after that, when we are getting that 23, then after that again I'm getting a sum as 31, which should not be like as an output. You got my point? What I'm saying?
You are saying that previously you got 21, is it?
First,
29.
yeah, 29. Better let me run that in my local and give you the output.
You said 20. I actually ran it. So just let me see. Let me just copy your current code.
So I sent you my output. So for the first time, for the first magic square, I'm getting minimum cost as 33, and after that it is getting updated with 29. And after
Okay.
that again I'm getting 31. That should not be
Yeah,
coming.
I saw actually this 31 answer.
Yeah.
So let me just run it. So you're initially getting 33, then 29, then 31 again, and then 21, then 29, 13, 17, 7 at the end.
Ma'am, can you share the screen, like ID screen?
Yep, sure. Yeah, so here, just let me see. What Kishan is doing, he's finding out if the given array is the magic square. He's finding out the minimum cost required. And if the minimum cost, like the temp min, is in any case smaller than the current minimum, then it is just replacing its values. I guess this is wrong. Let me just modify it. Did you took it as a global variable?
I tried, but after changing the code, I didn't. Maybe we need to take that variable as a static because all of my functions are static.
Okay, so 33, 29, 21, 13, 13, and 7. It's working now.
Yep. Fine.
So it was just a problem of like
Yeah.
declaring it as a global. That's it.
Like before adding this like second diagonal sum, I have
Yeah,
taken that, but
actually,
it was not working. So the main problem was there in the finding the second diagonal.
correct. Because what I saw that, oh, okay, let me just bring that out. Yeah, so even if your this diagonal 552 is having the sum equals to the rows, okay, but if this is not having now, like the 4, 5, and 6, then it's of no use. So that's why I figured that, like pointed that out.
Right.
Yeah. Okay. Good work. You actually solved it, so it was very nice. And guys, please, yep.
One second, please go back to the IDE. So why I'm asking is because it was not coming correctly. So if I assuming that the values are adding to 12,
The
but
values.
yeah, but when we go from left diagonal, left side bottom to up, then all of them add to 15. Like 6 plus 5 is 11, 11 plus 4 is 15. But the right diagonal, which is going from top to bottom, is adding up to 12. So is this pattern okay?
This is not a magic square.
Okay.
This is a normal matrix he has taken as an example. And according to this, he has manually calculated that what should be the minimum answer of it. And then he wrote this entire code to figure out if that, like the answer that he got 7 is actually working out or not. That is the entire purpose of writing this matrix.
Okay.
Clear?
Yeah.
Yep. So let's come back here. And yes, first question too is Aman. Yeah, Aman, did you revised your concepts of the linked list and were you able to do it? Or still you are confused?
No, ma'am, I am not confused.
Great. I guess we can help then. Okay, then. So let's start our session. So Kishan, can you quickly share the code for this insert function? Because I don't think that insertion is something which I need to explain now. So I'll just paste the code in this whiteboard link. Till then, yeah, anyone figured out this delete function? Anyone who figured out the delete function? Insert in the middle. Kishan, the insert into the sorted one. Okay, deleted one is done. Bhuvnesh, can you share the code for the deleted one? But I'll explain it obviously, but you can share the code. That will be needed. Whenever you are thinking of the deletion, and I have told you that you need to figure out the return type on your own. How to do that, I'm gonna explain that. Okay, so let's suppose your linked list is like okay, and if in any case I want to delete this 3, if 3 will be deleted, then your linked list will become 1, -11, 8, 6, and 5. Is your head changing right now? In this case, no. Then coming up to the next, let's imagine that I am trying to delete, like the number given is -11. So if I delete -11, the linked list will be 1, 3, 8, 6, and 5. In that case also, is your head changing? No. But by any case, if someone asks us to delete 1, then will your head change? And if your head is changing, like your current head will be 3 now, so your main function should also know that your head has been changed, because right now in your main function it is known that your current head is pointing at 1. But from the delete function, since you are deleting 1 itself, your head is becoming 3. So to avoid the confusion in such cases, our return type should be node. Okay, anywhere where your like head node is getting changed, in that case you should return your head node. Clear? Same thing goes with the insert function here. So in this insert function, it is okay if you have been given the linked list as, sorry, let's suppose your linked list given as 1, 7, 11, and 40. And I ask you to insert in this linked list -8. Where it should be inserted? At the start. So when I am inserting it at the start, then obviously its head is going to change. And if its head is going to change, again, the main function should know that head is changing, and hence our return type here is node. So every time you're writing any function, you should know that why you have written that specific return type. Clear? Okay. I'll ask you this question again in the coming questions, but I hope right now it's clear. So again, if you want to like insert any number at the start, like delete any number from the start, what will you do? Like let's suppose your position was 0. Then instead of like traversing in the entire node, you can directly check now that if your position is equal 0, in that case, you simply need to return. Yeah, correct. Move your head to head dot next. That means you can return directly from here head dot next. Clear? Okay. Now, other thing, there can be sometimes then that someone is checking if you have written an appropriate program or not. How? That means someone can give you the position as -1, -3, or let's suppose beyond the length of the linked list, it can be like let's suppose your linked list is 11, 8, 3, and 6, only 4 elements. But someone give you the position as 6 or 7. Then you can't delete any element from there, right? So you need to keep check of that case also. That is, if in any case position is less than 0 or position is greater than or equals to the length of the linked list, then in that case, you just need to return. What should be returned in that case? Why null? Why exception? Simply return the current head, na? Like you need not delete anything. You have to return your current original linked list. That's it. Now, in the case you have position in between, like from 1, because we have already taken care of the case for 0. So if your position lies between 1 and like length -1, because like indexing is starting from 0, what we can do in that case? Can anyone tell me that? Imagine you have this current linked list 11, 8, 3, and 6, and I want to delete 3. So how can I delete 3? Traverse to that position and then assign. Right. So traversing, first of all, is the first one. So here I will write up to where should I traverse? Should I traverse till the delete, like the position that should be deleted, or should I traverse before that? Before that. So I should be like here that while how come I know that I am at position like the current position -1? I have nothing, like I am not taking any extra variable. How will I know that? There should be some count or check you should be keeping, right? Yeah, we need to maintain a count. So in this case, you just take your count equals to 0, or you can take your count. Yeah. You can write here while count is less than position. If it is less than position, means it will continue till position -1. As soon as this is done, every time what you need to do, you need to increase your count and you need to move your head. Clear? Now we are at position -1. What should be done after this? What should be done after this?
I'm thinking after this, we can have one check if count equal to position, just to make sure.
No,
Um,
because we know that this count will run till till less than position, that is position -1. So now we are at, let's suppose I want to delete 3. So I am at 8. If I am at 8 and I want to disconnect 3, then I will be simply writing as,
Head equal to head dot next.
correct. Your current head, that is 8, its next should be pointing to head dot next dot next. Clear? Everyone, is this clear to you all? And then you need to return head, which you have not stored. So just make sure you do that every time. You can create a node th equals to head. And here, after this, you can return th. Clear, guys? I'm asking this to everyone. Is it clear to everyone? Okay.
Madam, one thing, you have not assigned th after in the below statement. Like, I feel that head dot next should be th dot next, second last line.
Yeah, what?
So I'm thinking second last line instead of head dot next. What is the use of th? We have not used.
See, I just now told you that return type is node, right?
Yeah.
So you like check the base conditions. That is, if position is equals to 0, you need to return head dot next. If by any chance the positions are like beyond the length of linked list, then you are returning head. But in any case, the position is inside the linked list also. Then in that case also you need to return something, right?
That's correct.
So you need to return the original node or original head. That's what I'm returning with th. Clear?
No, 1 second. So th needs to have one less element. So in this,
th is the original head.
okay,
It's not moving along with your head. The reason I'm copying it here is I want to preserve the starting index of the linked list.
okay.
Clear?
Actually, I was thinking that in delete, the return should be one less element which is removed.
What do you understand by the term return?
That the calling function should get the desired nodes with one whatever element at that position removed.
So if you are saying that I should be returning one position less than the deleted node, then don't you think I'm missing out on my previous linked list? I'm just returning one position before the deleted node, and hence I'm covering only half of the linked list, and half of the linked list I'm losing.
Isn't that the goal? I mean, no, not this. Like we are supposed to just remove the desired position element, then the remaining
No.
should go back.
The goal is that if you have a string and it has got a stain in here, then you need to remove this stain and attach the remaining string so that we are able to see this entire string with no stain. The
Yeah.
goal is not that if you have got a stain at some point, then just cut off this part and like
Stitch it.
give this part. No, what the thing that you're saying is that if we are deleting from here, then just return the part after the deleted portion.
No, my understanding is merge the before and after.
That is merged. Okay, that is merged. But how will your main function know that you have merged something?
Okay. So in this case, the head which is passed and the return node also returned, they are exactly same,
Right?
but that's not our goal. Our goal is that the return should be that element which is at that position should
No, it's
appear.
not. It's not. You need not print the deleted element. It's not the goal. Your goal is if you have deleted the element from the linked list, and if you are traversing now in your linked list, then that particular element should not be there.
Yeah, that's true. That's exactly what I also want. I shouldn't expect 8 or whatever 7 to be in the return. But in this case, if we see the code, the th will still have the element. We are not.
We are talking about addresses. Okay, understand this. So if at any point I have pointed this head dot next equals to head dot next, in between, suppose this was your link, in between these two links are interlinked. Okay, your
Yeah.
th was here and th still knows only this linked list. What you are thinking now that in between what I have deleted still persist with the th? No, it's not. The
Okay.
th is only stored for the reason of having the starting address.
Okay.
That's it. Like it do not, like with a single th you cannot imagine to have stored the entire previous linked list. Clear?
Okay.
Yep.
Okay.
And if it's still not clear, just try to traverse it on your own. Then you can come up with a better understanding. And if not, then obviously you can ask your question, right? Clear?
Yeah. Yeah. Yeah.
Okay, then so we'll move forward and we'll see the delete all function. And in this, you will be given some number int x. I hope you all remember what was delete all function. Yep. So in this, I'll just give you an example. Sorry, my bad. My bad. I just told you that day that it should be a sorted, but it can be unsorted as well. Just it will work both ways. And if in any case I am telling you that your x should be equals to 3, so you need to delete all the occurrences of 3, and your current linked list should be 1, 4, 8. Clear, guys? Okay. So how can we do this? Is it easy? Is it tough? Is it complicated? I don't understand your yes. Not easy. First traverse, it's okay. Moderate, okay. It is very easy. just we'll see how is it happening. First of all, yeah, in any kind of linked list, the first thing you should be aware of that your linked list should not be null. So you should check if your H is equal null. In that case, you need to return head only. Next is as you can see, there is expected that in the start itself, there can be lots of the similar data as given by your X. So in the start itself, you can start traversing while condition can be told by you guys. And okay, why is it not, Kishan, like H not equals to null? Yeah, first null check we did.
So I was thinking inside while h dot data equal to x.
But you should move your data, like you should move your head also, no? So it should be like where you should end your while loop. Like
Yeah.
let's suppose you find out that right now your head dot data is equal to X. Okay, so what will you do?
Then call the delete within the while loop. The same thing that we did previously.
So you're saying that as soon as you got this, then you're again gonna call this delete function, is it? Is that you're saying?
Yeah, that's my understanding.
Can't we integrate it in here so that it becomes easy?
Yeah, we can. So in that case, inside would be h dot next equal to h dot next dot next, like that.
No. Just think of the situation until where your while loop should go. Like as soon as you find 3, you need to stop and delete it, right?
Yeah.
So I'll not write the condition as of now for the while. I'll just write it inside. If in any case you have figured out your h dot data is equal X, then in that case, what will you do? Yes. Okay.
So h dot next equal to h dot next.
H dot next equals to h dot next. Okay. I'll write it. Need to delete this current element. So yeah, Vishnu is saying right that current head dot next, but the point is, Vishnu, that this current element is 3. Okay. Are you able to follow me?
Yeah.
And
That's
if you figured out that h dot data is equal X, that is obviously 3. Now what you are doing, h dot next is equals to h dot next, which is not correct because what you are doing, you're pointing this head to this one. So basically, you're not deleting your current element. Clear?
so okay. So the problem is how to get rid of the head. That
The problem is how to get rid of the remaining elements as well.
yeah.
So in the delete function, you all would have noticed that we were not checking for our current head. We were checking for h dot next, right? Like we reach the position -1 and then we check if like position what we were doing, that h dot next, that means which was your actual position, we were pointing it to h dot next, right?
Yes. So
Were
I
we
think-
doing it from the position itself? No. Yes, Vishnu, you can say what you're saying.
so I mean, I just take my step back. Instead of h dot next, we'll do h dot next dot data equal to x.
Yeah, that's
So
right. So instead of checking the current step, we should be focused on what's the next element. Okay, because this is your head. Let's suppose here is your data and here is your remaining linked list. If you check that this is X, then you can point it to here. We will later figure out how to remove this if this is also X. But right now, we need to sort the remaining linked list. Clear? Okay. So just figuring that out, I'll write here the condition as if in any case your h dot next dot data is equal x, in that case your pointer should be like h dot next is equals to h dot next dot next. Clear? We can compare it with the current scenario as well. This head dot next will check that like it is 3 and 3 is equal x also. So it will point this current head to 1. So it is working fine, right? In any case, if your current h dot next dot data is not equal to x, what you will be doing, you will be moving your head. That means, let's suppose my linked list was 1, 1, 3, 7, 4, 3, 8. This was my head. It checked if head dot next dot data is equals to x. Is it equals to x if x is 3? No. So if it is not equal, then obviously you need to move your head further. That means you need to move to the next position, right? So that to continue the process. Guys, you are able to follow. If this is not x, then there is a possibility the other number can be x or this number can be x. For that reason, you need to continuously move your head ahead. So head is equals to head dot next. Clear? Okay. So this while loop closed. Now you are every time checking, like this if condition, you are checking head dot next always, right? So I cannot put here the condition as h not equals to null. Why so? Because at any point, if your head is like, let's suppose at any point your head is not null, but its next is null. So what will happen? Head dot next will give you null and null dot data will give you null pointer exception. So for that reason, instead of checking for head not equals to null, you should check for h dot next not equals to null. Clear? Okay. Now everything is sorted. Only one thing you all forgot again is to copy your head somewhere. So it should be node th equals to h. Now you all understand that linked list from here to here will not be having any x element, right? After running this while loop. But there is a possibility that this first element can be having the element x, because we have not checked for that. So at the end, you can apply a if condition that if th dot data is equal x, then in that case, you can simply return from here th dot next. Clear? Otherwise, if it is not the case, then in those cases, you can simply return th. I hope this question is clear to you all. Any queries or questions you can ask me right now, or any confusions?
Ma'am, at which point are we initializing th? Oh,
At
okay.
the start, when
While-
we don't start to iterate.
Okay.
Any doubt?
No.
Okay then. Okay then, so we'll see our next question and want you all to tell me its return type on your own. I am not gonna tell you. So your current question is void distinct element. Okay, so in this case, this is given you a sorted singly linked list. The linked list look like this is your like sorted singly linked list. Your function is distinct function, where you will be given node head, and you need to return all the distinct element in the given linked list. Do you all understand the term distinct? No, it's not unique, it's distinct. Distinct means if one is present multiple times, then at least there should be one in your linked list as a result. If there are multiple 8s, then at least you should consider one in your result. Same thing goes for 30. That means every element present in your original linked list should have the presence in the resultant linked list. Just they should not be repeated. Like they should be present once, but they should not be repeated. Clear? Did you understood now what distinct means? Okay.
So
So
unique is the same thing. I mean,
no, unique is if I tell you the unique function, in that case, see, in this particular linked list, one is repeated, right? I won't take them in my resultant linked list. 4 is not repeated, I will add it in my linked list. 8 is repeated, I won't take it. 10, I'll take it. 11, I'll take it. So if it would have been the case of unique, this should be your linked list. Sorry.
okay.
Clear?
Got it.
But since this is the case of distinct, your resultant linked list should look like 1, 4, 8, 10, 11, and 13. Clear, guys? Yes, Aman, you are right. Remove the duplicates. Just keep one occurrence of each element. So do you guys want to give it a try? Just one yes. Okay, 2 yes, 3. Okay then. So now you know about the distinct. I also explained you the unique along with that. Unique function is also having the same function definition, just you know the different output for that. So if you guys are trying for distinct, try for unique as well, and then come up with an approach by tomorrow. Will it be fine? Or do you want me to discuss it right now? One we can discuss now. We'll give it a try. Okay, we can discuss now. Fine. The only thing I'm gonna discuss here is the return type for this. Can anyone tell me what will be the return type for this, the distinct one? And can anyone tell me what will be the return type for the unique one?
Hello.
Yes.
Ma'am, I have a question. Can we use set function to solve such kind of problems? Like we will retrieve all the data from particular node and we will store that data into a single list, and after that we will use set function.
Yes, you are right, Aman. You can use that, but it's like we are learning how to traverse in a linked list, right?
Yes, ma'am.
So it's better we do it in that way only.
Yes, ma'am.
Like it can be done. It's a thing that you can do it via linked list. It's not a problem. Like not the linked list set.
Yes.
Okay. But I'll recommend that you improve your like traversing in a linked list on your own.
Yes, ma'am. Okay, ma'am.
The return time for both of them should be node.
It will be note for both the cases at the end we need the linked list with new values. In case of distinct, will it be ever like that you are completely removing your head? Just think. Like anyways, if there are multiple ones occurring together, then also you will keep at least one with yourself, right? Or multiple fours occurring together, you will keep 1 4 with yourself. So you are not changing your head ever, right? Are you? Like
Yeah, yeah,
your head
in
is gonna be there.
correct. That's
So
correct.
when your head is not changing, there is no point of returning the node, right? It should be void. Clear. But in case of unique, you know that if like multiple numbers are occurring in the start, then obviously the head will be changed. So in that case, the return type will be node.
And one thing is there, if the calling function wants what are the distinct nodes, we should have node as the return type. No.
Vishnu, right now, the thing that you're confused with is that if I am returning th or if I am returning my current head, then you're thinking like I am returning the old linked list, right? But the thing is, once we are changing the links here, right? See, your head is the same. You traversed, you find out one is repeating, you removed it. You connected it with 4. Then 4 is not repeating, you got 8. 8, you took it in your linked list since it's its first occurrence. Again, you traversed, you found 8 and 8 again. You didn't took it. Then 10, took it, 11, taken. Then found 13, 13 also taken. But when 13 is repeating, then you cannot take it. And this is your final linked list.
Correct.
So head is old, head is the same which we got, but the linked list that is now formed is the new one. We have
Yeah,
got all the distinct elements, right?
right.
So in a linked list, it's never about the variable. It's about how you're pointing to the nodes. And that's why we are writing whole stuff like head dot next is equals to head dot next dot next. This is how we are pointing to the new nodes.
Okay.
Getting me?
Yeah. So, I mean, I'm trying to understand that how to differentiate when to use void and when to use node is
When your head is not changing, you got 1 as your head, and in the return also you are returning 1, then you should not have the return type as node. It should be void. But in any case, like this, delete all. In this delete all function, if all the threes are removed, then you are getting a new head, right?
correct.
If you are getting a new head, then obviously you should inform your main function that your linked list starting node has been changed.
Right. Yeah.
And that's why your return type should be node. It's as simple as that.
Okay.
Clear?
Yeah. But then in case if the requirement is that, get me the distinct elements of a node, then in that case, the return type would change. I mean, I understand that if the head is not changing, you return it void. This is like a general rule. but
Yeah, and in case of distinct elements,
correct.
your head is not changing, right? In case of
Yeah,
unique elements, it is changing.
right. But if I'm doing some operation after distinct on the return of that elements, then I would expect still that the new node should be returned rather than the old one.
Your question is not clear.
Oh, okay, okay, okay. So if someone says me get distinct list of nodes and I return the old node, even though what I'm doing internally is not his business. So he'll say that you are still returning the old stuff, but I asked you
But
for
if the internal stuff is not his business, then obviously what you are returning and what you are doing is not his business. He is only concerned about getting all the distinct nodes. And when he will try to traverse the linked list with the node, like the current node after using this distinct function, he will be getting the resultant linked list. Then what's the problem? You give me this. Okay, just imagine. You give me this head. You give me some linked list. I call this distinct function without any return type. I pass this head in it. And after this, I try to traverse in my linked list with this same head. And now I'm getting this distinct linked list, like distinct elements linked list. I'm
right,
getting the work done, right?
right.
Then why will the user be bothered about there is no return type or there is some return type? Like he doesn't care that. They just want the work should be done. If it is getting done, then it's fine for them, right?
Yeah. So when I mean, yeah, and the third step when you're writing traverse, it'll have all the elements which it started from.
You're not getting the point right now. You just try to traverse it on your own and then you will get it. This head, after going through this distinct function, will
Mhm.
have the links changed.
Okay.
It won't be having the old links.
Okay.
Okay. It doesn't mean that if we are calling a distinct function, it's a useless function. And if we are again trying to traverse this head node, then it will return us the same linked list. Then what's the purpose of this using this distinct function? Are we joking around here in this function?
Yeah. I mean, I got your point. Let me try it out. I was
Yeah,
thinking
please
it's a
do.
call by value. So the value has not changed.
It's not called by value, it's called by reference. If you are changing the like pointers, it is actually changing.
Okay.
Okay.
Got it. Okay. Yeah,
Yep.
I'll try. I'll try.
Okay then. So yes, thank you guys for attending today's session. Try to do this distinct and unique functions. And if not, then obviously we are gonna do. Distinct is quite easy. Unique is a bit complicated. So we'll discuss that in the class for sure. Okay then. Yeah. Thank you for attending the session. Bye.
Thank you.